The topic is generating binary search tree from traversals. Similar topic we have studied in binary trees, just binary trees. But these are binary search trees. And in binary trees, we studied that for generating a binary tree, we need any two traversals, and among that, one of the traversal must be in order. Pre-order plus in order or post-order plus in order. Any one of these combination must be given, then only we can generate a binary tree. Now coming back to binary search tree. For generating a binary search tree, if we are having pre-order and in order or post-order and in order, then we can generate binary search tree also by following that same old procedure. But in the example, I have only pre-order. What about in order? So I don't have to worry. In order traversal of binary search tree gives a sorted order. This is the property of binary search tree. So I can take the sorted order of these elements like 10, 15, 20, 25, 30, 40, 45 and 50. If I take the sorted order, then I will be having pre-order and in order. Then I can follow that whole procedure. Yes. So how many traversals should be given to us? Only one traversal is sufficient. That is either pre-order or post-order. In order I can find out. But without in order also, binary search tree can be generated just using pre-order or just using post-order. So we don't need in order. Without that also binary search tree can be generated. So just using pre-order we can generate binary search tree. Let us see how we can generate a binary search tree just using pre-order traversal. Let us create a binary search tree. For this procedure, I need a stack. So I'll take a stack. Let us start. Scan through this pre-order by taking one element at a time. So right now we are at first element, that is pre of 0. So for the very first key, create a node. Create it and make root point on it, and also take some temporary pointer p pointing on it. This is the first node. This is the very first node. So for initial part, we have to do it separately, right? Because root should point on that one. So this is the first step. Initial step, not a repeating step. Initial step. Now repeating step starts. First node is created. So binary search tree is ready just with one key. Now move to next. This element, is it smaller than 30? Yes, smaller than 30. So create a new node with some temporary pointer and set that value, make this as null. Make p's left point on this one because this is smaller. And push the address of 30 into the stack. Address of 30 into the stack and move p on this node. So now p is pointing on new node. Then next, this is repeating steps, right? Remember, this is repeating step. So one step over. It was small, so we inserted on left side. Otherwise, what we should do, we will see. Next, move to next element. Is it smaller than 20? Yes. So create a new node with the help of temporary pointer and insert the value, make this as null, make this point on this one. Push the address of that 20 into the stack and move p on new node. So this I have done it using t. Second, one more step. We have repeated the same thing. Now move to next one. This is 15. Is it smaller than this one? Is it smaller than this one? 10. It's not smaller than 10. Definitely, it is greater than 10. Yes, it is greater than 10. So it's greater than 10 means, shall I insert here or confirm whether it comes there only or not? I have to confirm. How? That element, that next element should be in between these two. It should be smaller than this one and greater than 10. So it should be in between 10 and 20, right? So it is not less than this one, yes. Else it should be greater than this one and less than 20. So where is 20? So the topmost element into the stack. Don't delete it. Don't delete it. Just check the data from there. 20. So it's greater than 10 and smaller than 20. Yes, 15 is greater than 10 and smaller than 20. Then create a new node with the help of temporary pointer, right? And insert that value 15, make this as null, make p's right child belong to this one and bring p upon this new node. Don't push the address. So this is the difference. When left child, we were pushing the address and going on new node. But when it is right child, just go on new node, don't push the address of 10. We don't have to go back to 10 now. 10's left child, it was not there. Right child, we insert it. So 10's role is over. That node's role is completed. So we don't need it in the stack. Next, move to the next step is repeating. 25, is it less than 15? No, it's not less than 15. Is it greater than 15? Yes, obviously it is greater than 15. Shall I insert at right side? No. You have to check whether it is lying in between the range of this 15 and this node. So what is this node? The address is here. Just take the data. 15 and 20. Is it lying in between 15 and 20? No, that is 25. So it's not in between also. So it will not come as a right child of 15. So if it is within range, insert it. Otherwise, what to do? Pop out this address from the stack and move P here. So upon 20, we got the address of 20. So in this step, we did not move I to the next element because it is not yet inserted. Step is completed. Don't move I. Let us start again. 25. Is it less than 20? No. Definitely it's greater. So if it is greater, it should lie in between this 20 and the topmost element in the stack. Topmost node in the stack is having 30. So it should be between 20 and 30. Yes, it is in between. So if it is in between, insert 25 on the right hand side. New node, link it, move P to new node. Don't push that in the stack. When we are creating right child, we are not inserting the address. Then also move to next element because 25 is inserted. Step completed. Repeat. 40. Is it less than 25? Current node is this one. No. Greater than 25? Yes. But is it lying in between 25 and this value 30? No. 40 is not lying in between these two. Then pop out this address and move P to that address. Don't move I. Let it be there only. Step is completed. Continue. 40. Is it less than 30? No. Is it greater than 30? 40? Yes. Compare the value from here to stack. When stack is not having anything means let it be infinity. Maximum value. Let it be infinity. So it's lying in between 30 and infinity. Yes. So add it as a right child. Create a new node with a temporary pointer t. 40 is inserted. Make this as null. And P is right child pointing here. Bring P on this one. Now I have shown you all cases. Now remaining two I will finish quickly. Now I is 150. 50 is it smaller? No. 50 is it greater? Yes, greater. But is it lying in between 40 and nothing is there? So it is infinity. So it's lying in between 40 and infinity. So insert 50 on this side with a temporary pointer and link it. Bring P upon that new node. And also move I. So that 50 is inserted. Now next element is 45. 45, is it less than 50? Yes, it is less than 50. So insert here 45 and link it and push the address of 50 in the stack. Address of 50 is pushed into the stack. Bring P here. Move I. I has reached the end of the pre-order. So the procedure ends and we got the result. So we have reached the end of an array and we got the result. So that's all. This is the procedure. I will write on a function and show you.